All right. Well, hello everyone, and welcome to today's webinar, How to Optimize Application Performance in the Cloud. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You're listening in using your computer speaker system by default. If you would prefer to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. In order to make this a more dynamic webinar, we encourage you to please submit text questions to today's presenter via the questions pane on the control panel. You may send in your questions at any time during the presentation, and we will answer them during the Q&A session at the end. This deck, along with other supplemental material, is available for you to download directly from the Handouts section on your attendee control panel. You will also receive a recording of the webinar shortly after. Now I'd like to introduce our speaker today, Warren Kruger, EVP of Customer Experience at LoadSpring Solutions. With more than 22 years of experience, Warren specializes in improving project, program, and portfolio management. He joined LoadSpring after launching implementation services for Microsoft and Critigen. A true believer in the project-based organization, he has implemented project management solutions for industries such as automotive, pharmaceutical, financial, IT, manufacturing, military, and government. Warren also developed and led PMOs for several Fortune 500 companies. Now, Warren, please take it away.
Thank you, Christian. So, welcome to Performance Matters, where it is my job to share with you our lessons learned in hosting project management applications in the cloud. There's several different topics we're going to hit today, and we're going to start with defining performance. So, what does it mean when we say performance? What does it mean when somebody calls in and says things are not performing as expected? And there is a couple tips and tricks to actually getting to how we truly define performance in the cloud for project management applications. Second topic is I'm going to walk you through some root cause analysis techniques for chasing and defining performance challenges. Third, we're going to review what I'm calling the top 5 performance enhancing recommendations. And there's many performance enhancing recommendations, but at least in the project management community, there seem to be 5 that always bubble up to the top. And fourth, we're going to discuss how do we automate performance management, and what does that mean, and how do we use that or leverage that to improve our end user customer experience or end user experience. So let's talk about defining a performance challenge. Number one, you really have to know the user community. What we see out there is when users are using any application in the cloud, whether it is a project scheduling application, a cost estimating application, we oftentimes don't know exactly where they're connecting from, what functions or capabilities are they using within the application, and this is really key to understanding whether or not there is a true performance issue, or at least the beginning of some of the variables that we're chasing when we're pursuing performance challenges. One of the issues that seems to come in frequently, and even this week, is we had a customer report in, hey, the application appears to be down. The application is down, and it kind of dawned on me that down, it really wasn't down when we looked at it. They were connecting in from a network location that had a significant latency issue, and we'll talk about that in a minute. And it appeared like the app was down. It wasn't down, but it's funny because slow now appears to be the new down in the industry. Many large enterprises, and I'll even go into capital project and program management efforts or initiatives, really cannot afford to be down, and that includes now slow performance of applications. So knowing the applications is also key. You really need to understand okay, is this application sensitive to network latency? Is the application use case going to throw a high volume of data or information into the database at during peak load? Is a user's function of deleting a significant amount of data during the middle of the day going to stress the application's performance? So you really need to know your applications as well. Third, to truly define a performance challenge, especially if a user is communicating there is a challenge, is you need to benchmark current conditions. A lot of times there is a very challenging time to define what slow means. Someone will call and say it's behaving slow, and we'll say, okay, well, let's dive in to benchmark exactly what you're doing, how long it's going to take, and then we'll compare that to our benchmark standards and try to identify where those gaps are so we can pursue and address those. Number 4, we will be defining expectations. Hey, Christian, sounds like I'm getting a bit of an echo here. There we go. Can you hear me?
Yes.
Okay, thank you. So number 4, we're going to define what an expectation is for good performance, or let's say expected performance, standard performance. And without that, you really are not able to understand if the end user is truly experiencing an issue or there is a perception challenge. And then 5th, identify the gaps and understand the business impact. I'm going to walk you through each of these steps, how we go about doing this with our user community. And I do like to start with when you say know your users, know your applications, it's really key that the community that is supporting the users and the applications know really what is happening in these applications. And that really comes down to good organizational training along with focused hiring. We like to say here, you really need to hire right. People who have a passion for technology, people who have a passion for applications. So getting the right players in is really key, and I'll highlight a couple of areas where that's more critical when we get into the technical discussion. So let's ask a quick poll here. I'm going to launch a poll. You should now see on your screen a question about what is your most reported performance issue? Or another way to phrase this is, what do you hear the most from your user community when they're complaining about slow performance in the cloud? Is it slow web page loading, slow navigation for streamed apps, slow calculation processing, slow file transfer, or slow batch processing time? So I'll give it a few minutes. We see a few votes coming in. And by the way, there are several other performance issues that can be reported. I do have a limitation in the poll to only include 5, so I've bubbled it up to some of the top 5 that we hear about here at LoadSpring when users call in. Okay, I'm going to close the poll. And let's share those results here. So it looks like a majority of the attendees hear about slow web page loading. So that really applies to web applications and especially high data intensive web applications where there's a lot of maybe transactions occurring. So we do hear that quite a bit. 25% for slow navigation response for streamed applications. And that really applies to fat client applications that are being streamed or accessed via something like a Citrix receiver. And then third, slow calculation processing. So that really deals with when an application itself is calculating a large volume of data on the server. How long does that process take? And in the case of I'll use project scheduling application, for example, that can take a significant amount of time if you have a very large volume of data in your project. All right. So close that poll. Now going to talk about how do we benchmark current conditions. This is such a key process, one of the most important ones to helping define user performance in the cloud. And the key here is you really need, if you do not know how to use the application, or let's say know standard capabilities and functions within the application, it's key to find a subject matter expert as you go through to learn what are, let's say, the top function points, most critical function points, and how long should they take based on history. And what you're looking at on the screen here are 7 examples, 7 functions that would apply to, in this case, a scheduling application. And when we have users report slow performance, we, at least with this type of scheduling application, we like to then go through and say, okay, well, we would like to understand some performance metrics between the top 7 reported slow actions for this application. Will you please walk through a brief test with us? So we get them online, we actually walk through the test with them, we time it, and that helps understand what they're experiencing. And then we compare it to our current tested range. Here you'll see for the first item there, launch application. Depending on the application, in this case, this scheduling application is a FAT client that spins up and is streamed through a Citrix receiver. So launch time is going to take a little bit longer. Tested range might be 35 seconds on the low end. Next capability down there, copying a project, might take a minute and a half, just over a minute and a half. Opening a project would take 5 seconds on the fast side. So you'll see for this particular application, some of the performance ranges that we have identified, and this varies substantially between applications. So if this is a project cost accounting application that is a web app, your launch time probably is going to be within 3 to 5 seconds versus 35 for a FAT client that's connecting to a large project schedule database. So it really does come down to the functions and the application. And then the column just to the right of the tested range is also key to define. So while we have a user on the phone in a support request situation, we also try to understand what their expectation is and why or where that expectation is coming from. And so when a user is comparing launching a web application to a FAT client through a Citrix receiver that's streamed, you really can't compare those. They're not apples to apples. So if the user is saying, well, when I launch a product like a scheduling web app or cost accounting web app, it takes me 5 seconds. Why is this taking 35? And so we walk through and educate the user. This lays that framework for training and educating a user on what's expected, what's normal for these functions as kind of the beginning of the process. Now, you'll notice these ranges. I do have on the second column over an identifier that says 8,900 activities in the project. What that means is we're also defining the volume of data. All right. So once we do that, we can plot this information and share it with the user and or the organization that to really understand, okay, what is their current performance, what is the user experiencing, and do we have any gaps? So the diagram or bar chart you see on the left shows each of those top 7 what we call long lead item capabilities in a scheduling application. And the expected duration, we see that there's 2 tests in there. We have or let's say 2 sides of the range. The blue bar represents the longest it would take. The green bar represents the fastest for the range, and the red line represents what the user is experiencing. And so what this shows is anywhere where you see the red line below the green bar, you know, we might be in a bad situation. Excuse me, or yeah, where the red bar is above the green bar, it's taking longer for the end user than is ideal. We want to manage that, control it, and then identify those impacts. On the right, you'll see that, hey, we have a situation or an issue where the user is experiencing a copy project and baseline creation that may not be in alignment with where we want it. And so we then start to perform our analysis. The other topic we look at is the data profile. So what you see on the screen here is understanding, at least in the context of a scheduling application, what does their data profile look like? So here you'll see projects, you'll see users, activities. This is typical data that sits within a project scheduling database, and we're counting it and we're showing the volumes. And this is information that we monitor and track because this will also indicate, based on certain attributes here and certain thresholds, what type of user experience might be expected. So you'll see database 4 there. There is a scheduling database with 61,000 projects inside of it, over 46 million activities embedded within those projects. And scrolling all the way to the right, you'll see some larger numbers for activity codes. The far right column, activity codes assigned to activities, 336 million assignments there. So this is data that really also must be understood. And sometimes you may have to engage the software vendor to learn where the true data bottlenecks are. We have learned that every customer does end up using project management applications quite different. That then spawns different data profiles. And based on those different data profiles, we learn things that, and sometimes educate the software vendor that they didn't even know. And so in the case of this scheduling application, this data profile, the gotchas are the high number of activity codes and UDF values that you see on the columns on the far right. So again, know your data, know the applications, and know where those bottlenecks begin to show up based on certain thresholds. In this case, database 4 with 336 million activity code assignments and 174 UDF assignments, we really want to see those numbers get down below honestly the 10 million mark. So this is we can tell right away that user experience is not going to be ideal just based on application architecture constraints and the data profile. So let's talk about how do we identify root cause issues. So you see on the screen here a root cause analysis diagram. This is also known as an Ishikawa diagram, formerly named after the Japanese quality innovator Ishikawa, who created this. It's also known as a cause and effect diagram, or informally as a fishbone diagram. But how we use this is we start with kind of the head of the fish. You'll see I've got poor end user performance identified there. This is really what we're pursuing to understand the root cause of. And from there, you move through primary categories, and I have 5 primary categories named. We've got a network category, a server hardware category, a workstation, user pattern, and application architecture. So based on that, you then dive into potential areas of findings with, or at least pursuits that you want to go see if they are contributing to a root cause issue. And so you'll see under network, we had users complain about slower performance cited when in the office. What that means is, okay, when they're working elsewhere, outside of the office, maybe from home, the network performs better and the applications perform better. So you may see a higher number of requests for employees wanting to work from home for that day or that week. Also, we look at things like network routing to the LoadSpring data centers. And if your data center happens to be in Boston and your user is, let's say your office location is in New York and it's routing user traffic through a headquarter office that might be located in Boise, Idaho, you know you're going to be sending data from New York to Boise, back to New York, then back up to Boston. It's just not optimized. So we want to look at that, explore that as a key area. Under server hardware, well, I'm going to talk a bit about this here shortly, but items such as, hey, we learned that there really isn't benchmark data for some of this large data volumes that we're seeing from this customer's use case. That really leads to uncertain definition of what is reasonable performance. We also want to dive in on server configuration, knowing that maybe we're seeing large data volumes. What does the vendor say? And in this case, the vendor has no guidance for these data volumes. So we're starting to learn some things about the big picture here. 4C, you'll see the workstation there. Varying Java versions in use might be one of the things we want to look at, maybe different browser versions. Is each workstation configured the same, or is it Wild West where everybody can bring their own device and have whatever they want on it? So those are some of the things we look at. The fourth area is user pattern, also known as use case. And in this particular case, you're seeing an example where there was no consistent data archive cleanup process. Therefore, the data continued to grow over time. Project after project was added, completed, and never archived. That started to create some challenges for this particular analysis. And then the application architecture there. This has to do with, okay, the vendor has architected it for really a certain functions, capabilities with certain data profiles, and they may or may not have information from their performance lab about data profiles that maybe go above and beyond their tested configurations, and that's what you're seeing in this case. So this can actually be a very effective tool. If you haven't used this to identify issues, you can use this for any quality issue area in any business. And this is used substantially even in business management outside of technology and IT or manufacturing. And it's best used, I believe, in a brainstorming fashion. So what you'll want to do is get your team members together, brainstorm. You can do this via web conference, such as what you see here as I'm presenting, or you can do this in person with a whiteboard. But it's best to brainstorm out, okay, what are we seeing, what's being reported, and what do we know as potential causes, or what do we need to pursue as potential causes? All right, let's go to another poll here. The second poll is, what is the top cause of reported performance issues? So again, I'm limited to 5 options here when I set this up. There's many more potential reported causes. But if you were going to take a shot at guessing, what do you think is one of the key top causes of reported performance issues? What would you report? I see some responses coming in: slowed network or latency, database issues. That's coming in. Give it a few more minutes. Go ahead and vote. Just click on one of the options there. All right. I'm going to close the poll, share results here. Interesting. So you'll see slow network or latency is reported frequently. 60% said that was the top cause. Database issues, that's a good one. I'll come back to that. Insufficient server resources, RAM, CPU, storage. At the end of the day, all of these are causes and for performance reported issues. But based on the industry and based on other industry surveys, the one that really, at least for, let's say, data-intensive applications, the one that always seems to bubble up to the top are database issues. And there's several reasons and causes for that, but that also gets to a primary recommendation that I'll share with you is you want to get the best database DBAs, database analysts, that you can get your hands on when you're supporting your user community with data-intensive applications. This community here at LoadSpring is one of the most strategic communities for helping us really knock down some of the performance-related issues that just bubble up through the database, whether it's record locking that occurs based on an architectural let's call it an application architectural defect, whether it is limitations based on application architecture, whether it's just data volume. Understanding that is key. So we'll talk more about that in just a minute. All right, let's close the poll and go back to my slides here. So let's talk about my top 5 performance enhancing recommendations. I've got 5 of them. The first one is to clean the data. And I'll talk about why in just a minute. You heard me mention that the #1 cause is database issues or database challenges for performance, at least what we see here in our support request and what the industry reports as the top performance related cause. And so keeping your data clean is really one of the best things. We call it your data management practices. Is one of the best things any organization can do to optimize performance. Now, clean data really means in the project management domain, making sure that you're archiving off old project data, maybe archiving out old resource information, and keeping your database clean for your production level data. And I'm going to share with you some tips and tricks to achieve that. You want to commonize your use case. You want to pursue technical environment confirmed bottlenecks. In many cases, you may have to engage the vendor, which we do. Number 4, pursue network application tuning. And number 5, which is obvious, number 5, workstation commonization. This is an interesting one, depending on the applications that you're running and whether it's a web app that requires an add-on, such as a Java or maybe a Citrix receiver, or HTML5 compatible browsers. All of this, if you're commonized, things get streamlined quite a bit. So with cleaning data, it's pretty obvious, right? More data equals slower queries. And in the project domain, focus areas are typically archiving out closed projects. And when we go in and do an audit, when there's a performance audit and our DBAs start to look at data, we find a high percentage of projects in these project management applications that are typically untouched for 6 months or more. That, it's just a function of projects finishing and not being pulled out. Also, watch for the 90-10 rule, I call it, where a small number of projects are your worst offenders. And in the case of the diagram you see on the lower right, I discovered that there were 10% of the projects that contained over half the data, or actually it was more than that. Let's see, it was 10% of the data in the database was controlled by one project. And that was a project that had been in flight for over 12 years. So it was 12 years of data that was starting to build up. Also, you'll see here 50% of the data in the database is assigned to 10 of the projects. Again, the 90-10 rule. So watch out for that. And we always recommend database segregation as you go through this. So you have your production or active data. You have your maybe projects that aren't done or closed. Maybe they're in financial closeout, maybe they're in litigation. So you need access to the data, but you don't want them in the production environment, so move them to maybe a closed out database. Same with archiving. This is a big thing that we see end users not really focusing on here. Custom field cleanup is another clean one. You heard me mention in the data profile about scheduling applications having custom fields that bloat over time. Keeping that data clean as far as not only what's configured in as being selectable by an end user, but the options that are selectable, and then removing old unused codes. Always ensure a DBA monitors during any cleanup process. Many applications are sensitive to large deletions, and in the case of cleaning up and moving and deleting, you want to make sure that DBAs are monitoring it, and you always want to schedule a database maintenance after a major cleanup program, because they then can go in and optimize the database, reclaim white space, and we get, you know, as far as performance goes, the biggest bang for the buck is right there when we do kind of a database reorg after a major cleanup. Users see anywhere from a 40 to 50% performance improvement for those long lead data items in the scheduling applications that we host here. All right, number 2, commonize use case. Why? Lack of common usage or data structure rules creates unnecessary data growth. It also makes it difficult to analyze and report across business units when you have different data structures. So the goal is to drive global consistency while enabling just enough business unit freedom for the unique reporting or management needs. The way we like to recommend going about commonizing the use case is perhaps starting a change transformation program focused on what does each cross-functional department really need for codes? What are their, if it's project management application, what are their update cycles? And we like this concept of a RACI matrix to help identify responsibility, accountability, control. You might have heard of the RACI terminology. We like to use that when it comes time to understanding how best to commonize use cases and getting business owners from each of the different business areas to really own the use cases and then commonize them across the cross-functional departments. Of course, you have to formally roll out and train the user community with the change program. We do recommend mandating that new projects follow the new data rules, where over time you can revise existing projects. You don't have to go back and, you know, any, let's say, in-flight production project and change the data or revise it to fit the new rules. But it's a very easy, it's low-hanging fruit that any new projects that start go ahead and mandate and adhere to the new data rules. So with the third recommendation, yes, this is what I call the mutual conspiracy: pursue technical environment enhancement. The reason I call this a mutual conspiracy is here we're, you know, our organization is full of project management experienced people, but also technology experienced people, IT, and this is very tangible. We know that, okay, how big are the servers, how much memory is on them, how many CPUs are on them, what is the 7-day average load for those servers, what's the peak load, and do we see anything starting to tap out? But we've learned a couple tough lessons here. We have learned that adding RAM to the memory does not result in faster performance always. In fact, most of the time it doesn't. Adding more cores or CPUs to the server does not, especially if the application is not architected to take advantage of it, does not help performance. So it's not as clear-cut as you would think. And so our recommendation is to monitor and tune versus add hardware. You know, organizations have added, I'll say we have added millions of dollars of hardware to try to test and see if performance is improved. And in many cases, it's not. It comes down to things such as memory arguments in the web application, or database SGA settings, open cursors, processors. So you'll see those other key settings on the right. And in the case of Citrix Farm, something that we leverage for projects in remote locations with low bandwidth scenarios, if their Citrix Farm is set up for low bandwidth settings, which optimizes the data traffic and makes it much easier to use sitting in a construction trailer, maybe in a remote location. So, again, you do want to pursue this. You do want to monitor it. We do monitor, and in fact, you'll see here that under the Citrix Farm, the memory is at 89%. That's a red flag for us. Whenever we see that monitor alert going off, we right away start to think, uh-oh, we are starting to reach capacity. It's time to add a new Citrix server to the Citrix Farm. And that can, distribute the load and start to lower the memory 7-day peak loads that we're starting to see. Okay, recommendation number 4, pursue network, and in concert with network, application tuning. And you'll see at the bottom of the screen here, this week, many users who are using cloud applications experienced performance issues. This was GeekWire's notice came out November 6th at 10:33 a.m. And then Level 3 Network Operations tweeted at 1:27 p.m. that, oh, sorry, we've experienced a disruption affecting some IP customers due to configuration all restored. When this happens, it's really challenging to communicate and resolve. Well, it's easy to communicate. It's challenging to resolve if it's out of your control or beyond your control. And this is actually quite rare. I'd say maybe from all 5 data centers that LoadSpring has, we might see network disruptions at this level maybe 3 to 5 times a year. And they're usually resolved fairly quickly when they do occur. So what we want to focus on is what's within our control. And within our control, we can start to explore between where the user is and the data center that they're connecting to. Things such as number of hops, are they going through a proxy? What is the latency from their location to the data center? Let's do some speed testing, some route tracing, and look at that information. And then the network round trip delay that I shared with you, where a user's in New York, they're connecting to the Boston data center, but due to their office's networking protocols, when they hit a web app, they have to go through their home office in Boise, Idaho, then back to their satellite office, then up to Boston. That's not ideal. So we work with your organizations, or have worked with your organization's networking personnel to say, hey, can we just whitelist the LoadSpring URL so that then your users can go direct from New York to the Boston data center and speed things up. And so you always want to look for that as part of your pursuit, and then keep in mind that next bullet, constrained network options. We've got a lot of experience with understanding low bandwidth scenarios, just because the project community is not always in a high-speed situation. So those are items as well that you want to pursue, especially if it's a streamed application. And recommendation number 5, commonize the workstations. So you'll see I've got in parentheses Java and Citrix. Those are 2, at least in the project management domain, 2 of the add-ons that go onto workstations that can cause issues. So you always want to look at the add-on consistency. Are you using the tested configuration for your application for a Citrix receiver or a JRE, a Java runtime engine add-on? Also, you want to look at what we found is some users are running multiple versions. That can be an issue on the same computer. So, our recommendation is, okay, maybe that's required because you have another application that requires a different version, but we want to work with your local workstation and IT community to make sure that they don't conflict with each other. So there's some tips and tricks there you want to look at. You also want to look at your browser. Confirm that you're using a supported version. make sure your security settings are all identical across all the workstations, and then any virus scan software compatibility. We had one organization that ran into a scenario where their virus scan was actually competing with the software itself and slowing it way down. And so once we isolated that, kind of paused the virus scan, performance returned to as expected. We then had to work with them to understand where those conflicts were, and they were able to tune their virus scan software to prevent that conflict. So looking at each user's workstation, commonizing them, making them consistent really does help. All right, the last poll here, poll number 3. So I've just launched this poll, and the question is, providing more monitoring insight, which of the following would you like improved visibility into? So whether you are an administrator, an IT person, or even a project management owner, or work within project management, do you have one here, or let's say multiple, select all that apply, please. Do you have a couple here that you would like to see and even maybe increased visibility into as an administrator, or increased visibility into as an end user? And the options that we're pursuing here are, would you like to see what your application data profile looks like? And perhaps set up some alerting so that when you reach a certain threshold of your data, we then can alert you. Or what about network performance or functional application performance and alerting? These are areas that we're getting more requests for, and we'd like to crowdsource which ones are at the top of your list. Okay. I'm going to close the poll. We're going to look at these results here. And, oh, this is great feedback. So we see half the voters out there would like to see application data profile reporting. 67% would like to see network performance reporting and alerting. And this is something that we will be adding to our cloud access portal called the LoadSpring platform. And then functional application performance and alerting. Yeah, that one's a little bit trickier, but I'm a little surprised that one didn't get a higher vote score, because usually it's the end users who are the ones communicating there's performance issues, raising support requests. And it would be nice, we have some customers say it'd be nice to know before the end users if a particular application function is not behaving, or let's say performing as expected. So thank you for that. Good information. What we do is we are currently working on an initiative to bundle all of this information together, application data profile, network performance profiling, and functional application profiling, making it more available to cloud administrators for the applications that we host. All right. Now I'm going to wrap up with one of the capabilities that we are getting more requests for, and it's really, okay, how do we automate this? What you're looking at on the screen is a list of that scheduling application's key slow functions or actions. You're looking at the expected range, and then you're looking at a day-to-day test. So we have now configured a test that actually behaves just like an end user. It opens the same project every morning before all the users log in. It is an 8900 activity project. It processes each of these functions through the front end and gives us this timing. And what happens is we then do get alerted when something is beyond the threshold. And this is what we call LoadSpring's APM, Automated Performance Management. And we're exploring understanding if users or administrators would like this for other applications as well, besides scheduling applications, especially around project cost accounting applications where use cases vary so much and data volumes vary so much. But the nice thing here is we can provide that early warning. And what we're one of the things that makes this key, if you pursue automated performance management yourself, which you can do, we actually have some of our own customers who do functional application performance testing themselves. So we've worked with them to allow this. But here are a couple of key things if you pursue this. Number one, you want to make sure that you do test as a user. Simulate an end user. That's really the most accurate way to test. If you start to do things like just sniff bits that's going through, let's say data bits that are traveling through the network and chasing time, we've learned that that doesn't really give an accurate perception of what a user is experiencing. So you want to make sure you're mimicking what users do. Always have consistent test actions and consistent test data, meaning you can't take a 20,000 activity schedule, put it into one database, and then take a 10,000 activity schedule, put it into a different database, and compare those results. It'll be apples to apples, and you won't get that side-by-side comparison. So make sure you're always using the same test project and the same test functions as you go through putting that into maybe different databases or different data profiles. We like to initially profile hourly. This gives you kind of a clue for where the peak load is hour to hour during your workday and during your work weeks. But then we just execute the test every morning just to alert, to say, okay, is anything running outside of the norm as far as the end user function? And then we send out the early warnings, and we can actually tip off the end users in advance so that we can kind of almost prevent support requests that come in when customers experience maybe a user slowdown due to like the network. Our automated test platform would have shown us when that level 3 network outage occurred, would have shown us the issue, and we could have tipped off the users in advance. So that's one of the key things. All right. So with that, that concludes the content that I have for today. I do have 10 minutes left to walk through a few Q&A, questions and answers here. And just taking a quick look, I have a question here that came in. How does LoadSpring address performance issues that come from defects in new releases of software? And an example cited here is Oracle Primavera P6 version 17. Okay, so yeah, how do we address performance issues? Well, anytime a new application comes out, whether it is a minor point release or a major update, we go through an app qualification process. And this is key for us, number one, understanding what does the architecture look like, because during a major update, such as the one referenced here, P6 version 17, we see database version requirements change, web server requirement changes, so they can be very significant. So we go through an app qual process to make sure that there is either a good understanding of what these new architectural requirements require. Then we also go through this functional end user testing to say, okay, we know what standards are now based on current versions. How does it perform? So we'll run through our battery of tests and compare those. And in some cases, we see significant improvement. In other cases, we actually see significant slowdown to the point where it's a showstopper. We cannot recommend the upgrade for our customer base. Next question here says, how does LoadSpring work with the network team, our network team, to help identify latency that may be occurring from the internet service provider? Okay, so LoadSpring does have network engineers on staff, and what we'll do is we like to connect our network engineers with your network engineers, your organization's network engineers, and go through a set of tests and help isolate where the bottlenecks are. So this is not necessarily always a fast, easy thing, but what it is a bit of kind of a troubleshooting web conference. Sometimes we can resolve a bottleneck, find a bottleneck, and resolve it within 5 minutes. Sometimes it might take a couple hours of troubleshooting, but we are geared and ready, and that's really what you have to do. There's no shortcuts there. Okay, how can LoadSpring support archiving old data that is clogging up my production scheduling database? So this is a good question, because when an organization has 61,000 projects, like I showed you earlier, in one database, it can take a huge amount of effort to begin to archive that data off. You open up the application, you archive it out, then you delete it. And if one of those projects takes a user 20 minutes to accomplish that, and you're trying to, let's say, archive 70% of the projects, that could equate to a significant, years. It could be years to actually archive that. So we do have some utilities to migrate information and consolidate information from one project management application database to another. And that is because automating that and batching it is really the only feasible way. We can help you as an organization pursue, let's say, helping clean with some of our utilities. You can also write your own. In fact, some of the applications do enable scheduling jobs. Primavera P6 is one of them, where you can schedule job services to export and import projects. But there's a couple of limitations with that, and we know what those are. We can help you through those. All right. And then finally, last question here. If we were to move some of our applications to LoadSpring, how do you help us keep the system tuned after the initial implementation? For example, some of our more complicated applications change over time as different projects, users, and initiatives hit the system. So they may behave fine today, but in 12 months after the deployment may not. How can you help us make sure? Well, yeah, this is very simple. We have our monitoring in place. And this is something that any organization can define or set up. But if your monitoring is in place, you get those early warnings, and you can reach out to the organization in advance. So that, one of the examples is that 61,000 project database. That was a legacy database that that customer migrated into the LoadSpring Cloud. What we've learned is, wow, okay, if we can prevent that, then we'll never run into those performance issues. So what we do is we set a monitoring, as I showed you, that explores not only just the functional use, but we have database monitoring in play, server monitoring in play, and we try to head that off early so that the users never even experience the performance decline. The other thing is, it's important we stay very close to you during onboarding. So an example is if we have a 3-phase deployment process where you're bringing on 3 different waves of users, let's say one group of user per quarter, we have to stay in touch with you to understand what those volumes are, because it is possible to where you might have a huge user shift and data shift that presents a new use case that we haven't seen before, so we're not monitoring. So we'll want to communicate very closely with you through that, and we have an onboarding process. It's a proven onboarding process where we can really monitor. We have an onboarding dashboard. We can monitor with you different risk areas and make sure that things are smooth for your end user community. Okay. So Christine, yeah, you're welcome. That's a wrap. I'll send it back to you for closeout.
Yes, thank you, Warren, and thank you everyone for attending today's webinar on how to optimize application performance in the cloud. If you have any other questions, please go ahead and email us at information@loadspring.com, and our experts will get back to you shortly. You'll also receive a follow-up email within 24 to 48 hours with a link to view a recording of the webinar. As a reminder, we do have a couple of handouts available on the control panel in the handout section. On behalf of the LoadSpring team, thank you for joining us today, and have a great rest of your day.